Dear students, today we are going to discuss about the topic nomenclature of cycloalkane and alkadiene. Nomenclature of cycloalkane and alkadiene. First, we have discussed about the nomenclature of cycloalkane. The cycloalkanes are named by using similar rule, but prefix cyclo is used indicate the cyclic compound. Prefix cyclo used immediately precede the name of the parent. Is the general formula prefix plus cyclo plus parent plus suffix. Prefix plus cyclo plus parent plus suffix. This is the nomenclature of cycloalkane. When a ring is present, the cyclo the cyclo prefix is used. When a ring is present, cyclo prefix is used. This is prefix plus cyclo plus parents plus suffix. Prefix indicate what and where are the substituents. This is the prefix. What is a cyclo? A ring is present, cyclo is indicate. Parent compound, how many carbons are in this ring? That is the parent. Suffix indicate the what is the functional group. That is the suffix. First rule is to find the parent cycloalkane. In this case of cis carbon ring is there, therefore this cyclohexane ring is the parent cycloalkane. Next, cycloalkanes name, the second rule, the name and the number of the substituents. Name and number of the substituent. No number is needed to indicate the location of single substituents. No number is needed to indicate the location of single substituent. In this case, the substituents, no number is needed. This compound, the methyl cyclohexane. The nomenclature of methyl cyclohexane. In this case, tertiary butyl cyclopentane. Tertiary butyl cyclopentane. And next rule, for rings with more than one substance, begin numbering at one substance and proceeds around the ring to give the second substance the lowest number. When numbering clockwise, numbering anti-clockwise. In this case, numbering clockwise direction. In this case, clockwise direction, numbering the anti-clockwise direction. Therefore, in this case, for the ring with more than one stems, the begins the numbering at one substance and proceeds around the ring gives second substance the lowest number. When two or more substituents present in cycloalkane ring, the substituents indicate with the lowest possible number. Lowest possible number. This is the correct naming numbering clockwise. This is the substance is in the position of on and third position. On and third position. But in this case, the numbering of substance is on and fifth position. Therefore, the lowest numbering in this case. Therefore, this is the correct IUPAC rule. This is incorrect. When two different substances, number the ring to assign the lower number to substance alphabetically. In this case, ethyl or methyl group is present. The ethyl alphabetically number the compound. When a compound present in two different substances, in this case methyl group and ethyl group, therefore the first numbering the ethyl. Ethyl is alphabetical order. E is the first, then methyl M. So E is the first. This is the correct. On ethyl, 3 methyl cyclohexane. This is incorrect. 3 ethyl on methyl cyclohexane. The two different substituents number the ring to assign the lower number to the substituent. Lower the number to the substituents alphabetically. In this case, ethyl methyl group, the ethyl is the first position. Therefore, the name the first ethyl on ethyl 3 methyl cyclohexane. In case special case, not the special case of alkane composed both ring and a long chain, if the number of the carbon in the ring is greater than or equal to the number of the carbon in the longest chain, the compound is named as cycloalkane. If the number of the carbon in the ring is greater than or equal to the number of the carbon in the longest chain, the compound is named cycloalkane, named as a cycloalkane. There's two different examples is there. Then the naming of the compound containing both the ring and long chain of the carbon. This is the example. This is the fourth carbon, sixth carbon. Therefore, the parent chain is cyclohexane. Their IUPAC name is butyl cyclohexane. Understand? The contrast two different examples. The cyclohexane ring is and long chain also present. In this example, the long chain have 4 carbon. Cyclohexane have 6 carbon. Therefore, the parent chain is cyclohexane. Therefore, butyl cyclohexane. In this case, more carbon in the 6. Cycloalkane ring have 4 carbon atom, but it's in this case 6 carbon atom in this longest chain. Therefore, the number is the parent chain is cycloalkane. The parent chain is the longest chain. The parent chain is longest chain have 6 carbon. 6 carbon parent chain. Parent chain have 6 carbon atom. Hexane. 6 carbon atom. This is substituent cycloalkane substituents group, that is on cyclobutyl hexane. This is the IUPAC name. These are the two different examples. In this case, more than the longest chain have more number, that is the parent compound. But in this case, the cyclohexane has more carbon atom. Therefore, the cyclohexane group is parent compound than the butyl group. More examples: ethyl cyclobutane. On secondary butyl 3-methyl cyclohexane. On 2-dimethyl cyclohexane. On 2,4-triethyl cyclopentane. These are the more examples of cycloalkane. Next, the cycloalkanes naming the nomenclature, common name nomenclature. This is the KUHSsyllabus. Some organic compounds are identified using common names that do not follow the IUPAC system of nomenclature. Many of these names were given ago before the IUPAC system was adopted and are still widely used. Additionally, some names are descriptive of shape and structure like those below. The common nomenclature is based upon their shape and structure. Some examples: this is the cubane, housing, 5-membered ring housing, cubane, based upon the shape of the crystal, and churching, basketing, based upon the shape of the crystal. There are common names: cubane, housing, churching, and basketing. Next, we have discussed about the alkadiene. What do you mean by alkadiene? Already we have discussed in the nomenclature of alkene. Alkadiene, alkene, the general formula of alkene. General formula of alkene is CnH2n. This is the alkene. But in this case, alkadienes 2n minus 2. CnH2n minus, similar to alkene. The molecular formula similar to alkene by Ne. Next, many compounds containing 2 or more double bonds are known as alkadiene, alkatrienes, alkatetraenes, and so on. The suffix denoting the number of the double bond. Suffix indicate the number of double bond. The location of each double bond specified by appreciate number as illustrated below. Many compound contain two or more double bond. When two double bond, they contain alkadine. Alkadine when contain two double bond. The organic compound or saturated chain contain when an organic compound they containing two double bond, that compound is known as alkadine. Alkadine. When three double bond, alkatrienes. Four double bond, alkatetraenes. Therefore, the suffix denoting the number of the double bond. The suffix tri, di, tetra that indicate the number of double bond. The location of each double bond is specified by appreciation number as appreciation. The location of the each double bond specified by appreciation. In the IUPAC nomenclature, alkadiene and the alkadiene is used. The appropriate number is also indicate the double bond, location of the double bond. And this is the example. Alkadiene general formula CnH2n-2. This is the general structure of alkadiene. General structure of alkadiene. This is the example on 2-butadiene, on 3-butadiene, and on 2,3-butatraene. These are the example. On 2-butadiene is alkatraene. Example of alkatraene. These two are the example of alkadiene. And further classification uses the relationship of the double bond to each other. The alkadiene is classified into three type. The first one is the cumulated double bond. The second one is the conjugated double bond. Third one is the isolated double bond. First, we have discussed about the cumulated alkadiene. In this case, cumulated alkadiene onto alkadiene is indicate the cumulated alkadiene onto alkadiene. These are the similar to substance said to have cumulated double bond. This is the example of cumulated alkadiene. That is the double bond have on two position, 3-4 position. The double bond this on 2. The double bond is on 2 position or 3-4 position or 4-5 position. This indicate the cumulated die. Next, on 3 alkadiene, that is indicate the on 3 alkadiene that indicate the conjugated double bond. In this case, on 3 pentadiene, this double bond are adjacent each other. Therefore, this is known as conjugated die. In this case, on 3 position double bond. On 3 alkadiene indicate the conjugated die. On 2 alkadiene indicate the cumulated die. Understand? These are the example on 3 pentadiene. This is the conjugated double bond. This is the conjugated double bond have in this position adjacent to each other. Next, another example, 2-methyl on 3-butadiene. And third, isolated double bond. Isolated alkadiene. These are the example. The double bond separated by 2 or more single bonds. Double bond are separated by 2 or more single. That is isolated. In this case, they are double bond separated by 2. Therefore, 2 or more single bond. Double bond are separated by 2 or more single bond. Therefore, it's known as isolated double bond. In this case, double bonds have adjacent to each other. In this cumulated double bond have adjacent to each other. But in this case, conjugated double bond, the double bond are separated by only one single bond. That's known as conjugated double bond. That is on 3 alkadiene. That indicate the conjugated double bond are separated by one single bond. But in this case, isolated double bond are separated by 2 or more single bond. Okay, is the nomenclature of alkadiene is similar to the alkene. Their general formula CnH2n minus 2, that is similar to alkyne. The nomenclature rule are similar to the alkene. The general rules of UPSC nomenclature are of alkadiene is similar to the alkene. Please follow the topic. Alkene. The rule for UPSC nomenclature is similar to the alkene. The rule of UPSC nomenclature of alkadiene is similar to the alkene. Okay. Thank you all.